Nvidia lost $1 trillion in market value in 3 weeks. Not because their technology stopped working, not because demand disappeared, but because the market suddenly woke up to something that's been hiding in plain sight for 7 years. Google has been quietly building chips that might be better than Nvidia's for the one thing that matters most right now: artificial intelligence. These aren't prototype chips or future promises. Google's tensor processing units, TPUs, are now in their 7th generation. They've been powering Google's own AI systems since 2018. They're the reason Gemini 3 runs so efficiently compared to competitors. And now, for the first time, Google is selling them to outside companies instead of keeping this advantage locked inside their own ecosystem. The question isn't whether Google's chips work. They demonstrably do. The question is whether Nvidia's seemingly unbreakable dominance, 80% market share, $3 trillion peak valuation, backlog orders stretching months, just developed its first serious crack, and whether that crack is about to become a chasm. Let's start with what actually changed. Google has offered TPUs through their cloud services for years. If you wanted to use Google Cloud, you could access TPU computing power as part of that package. But that's different from what's happening now. Companies are beginning to inquire about using TPUs in their own data centers, not just renting compute time through Google's cloud, but actually deploying Google's chips in their own infrastructure. This matters because of who's asking. Meta, which has spent tens of billions building AI infrastructure on Nvidia chips, is reportedly exploring TPU options. Banks that need high-frequency trading capabilities are expressing interest. Companies that previously had no alternative to Nvidia suddenly have one, and it comes from a company with deep expertise in exactly the applications they're trying to build. The implications ripple outward in ways that explain Nvidia's market value collapse. Nvidia's dominance hasn't just been about having the best chip, it's been about ecosystem lock-in through something called CUDA, the software framework that makes programming Nvidia chips relatively straightforward compared to alternatives. Once you've built your systems around CUDA, switching to different hardware becomes expensive and complicated. Google's approach threatens that lock-in by offering not just chips, but an entire integrated stack. They've developed their own programming language called JAX, specifically designed to work with TPUs. But crucially, they're also showing that TPUs can work with other software ecosystems. You're not forced into a single proprietary framework the way NVIDIA's CUDA creates dependency. This vertical integration is Google's fundamental advantage. They didn't design chips in isolation and then figure out what to do with them. They built AI models, discovered what was inefficient, and then designed chips specifically to address those inefficiencies. DeepMind's AI researchers work directly with Google's semiconductor team, iterating on both software and hardware simultaneously. That's very different from Nvidia's approach. Nvidia makes general-purpose graphics processing units that happen to work well for AI. They're flexible, capable of many different applications beyond machine learning, but that flexibility comes with trade-offs. Application-specific chips, like TPUs, can be optimized for specific workloads in ways general-purpose processors cannot. Jensen Huang, Nvidia's CEO, argues that GPU flexibility is actually an advantage. His chips can accelerate graphics, handle scientific computing, run simulations, and train AI models. Why limit yourself to application-specific hardware when general-purpose chips can do everything? The counter-argument is straightforward. If the application you care about is AI and machine learning, who cares whether the chip can also render video game graphics? You want the hardware that performs your specific task most efficiently. And if TPUs train models faster while consuming less energy, the GPU's flexibility becomes irrelevant. Energy efficiency is where this gets particularly interesting. The bottleneck in AI infrastructure isn't chip availability anymore, it's power. Data centers running AI workloads consume exponentially more electricity than traditional computing. Training large models requires staggering amounts of energy. Running inference at scale for millions of users multiplies those requirements. If Google can demonstrate that TPUs deliver comparable performance while using significantly less electricity, that becomes becomes a decisive advantage. Governments worldwide are concerned about data center energy consumption straining electrical grids. Companies are facing rising power costs and difficulty securing adequate electricity supplies for planned facilities. Any chip that does more with less power solves a problem that's only getting worse. This is what analysts mean when they call efficiency the winning formula. It's not just about raw performance, it's about performance per watt. How much computation can you extract from each unit of electricity? In a world where power availability limits how much AI infrastructure you can build, efficiency determines who can scale. Google's Gemini 3 showcases this advantage. The model runs remarkably efficiently compared to competitors, not because Google's AI researchers are better than everyone else's, but because their models are optimized for hardware they control, and that hardware was designed specifically for these workloads. The entire stack works together in ways that aren't possible when you're buying chips from one company, cloud services from another, and developing models with a third. Amazon has been pursuing similar vertical integration with their Trainium chips, now in their third iteration. Like Google, Amazon recognized that building their own hardware optimized for their specific AI workloads could provide advantages over buying general-purpose GPUs. Early reports suggest companies are using Trainium not just for inference, running trained models, but increasingly for training as well, which has traditionally been Nvidia's stronghold. Then there's Broadcom, which has been designing custom AI chips for major tech companies. Their stock jumped 12% in a single day as investors recognize that AI chip design might be proliferating beyond Nvidia's ecosystem. OpenAI is reportedly developing its own chips. Meta has been investing heavily in custom hardware. Apple, with its $2 trillion market cap, has deep expertise in custom silicon from years of designing processors for iPhones and Macs. This creates a scenario where AI chips could become commoditized, not in the sense of being cheap, but in the sense of having multiple viable suppliers rather than a single dominant provider. That's devastating for Nvidia's valuation, which was built on the assumption they'd remain the only game in town for high-end AI computing. But here's where Nvidia's counterattack becomes interesting. Jensen Huang isn't just selling chips, he's making strategic investments in AI companies that commit to using Nvidia hardware. The company put $100 billion into OpenAI along with preferential access to their latest chips. They've made similar investments in Anthropic and other leading AI developers. This creates a different kind of lock-in. If Nvidia is simultaneously your chip supplier and your investor, switching to Google or Amazon hardware means potentially losing access to capital and strategic partnership. For startups burning enormous amounts of cash while training models, Nvidia's money matters as much as their chips. The question is whether that strategy can hold against vertical integration from companies that don't need outside capital. Google, Amazon, Microsoft, and Meta are generating sufficient cash flow to fund their own AI development. They don't need Nvidia's investment, which means they're free to optimize their infrastructure however they choose. If Google's TPUs or Amazon's Trainium chips deliver better efficiency, those companies will use their own hardware regardless of what Nvidia offers. OpenAI represents the interesting edge case. They rely on Microsoft's infrastructure, which has been built primarily on Nvidia chips. But OpenAI is also developing custom hardware and exploring alternatives. If they conclude that TPUs or other options provide better performance or efficiency, their deep partnership with Microsoft won't necessarily prevent them from switching, especially if Microsoft itself decides that custom or alternative chips make sense for Azure's AI offerings. This is the battle that's unfolding right now, and it explains the violent price action. Nvidia's stock breaking below $180, a key technical level, triggered waves of selling as traders recognized the company's dominance might not be as secure as priced into that $3 trillion peak valuation. $1 trillion of market value evaporating represents reassessment of how much monopoly power Nvidia actually has. But here's what makes this particularly complex. The market isn't simply moving that $1 trillion from Nvidia to Google. Google's market cap increased substantially, yes, but the capital isn't just rotating within tech. Some of it fled to value sectors, healthcare, consumer staples, other defensive positions. Investors aren't necessarily betting on Google winning as much as betting on Nvidia losing its stranglehold. Oracle's price action demonstrates this confusion. Initially, Oracle Google rallied on the theory that more competition in AI chips would benefit hyperscale cloud providers. Then Oracle dropped back into negative territory as investors realized the picture is more complicated. If Google, Amazon, and Microsoft are all building custom chips, does Oracle benefit or lose out? If the hyperscalers have more options, does that help providers like Oracle or hurt them by reducing their own leverage? The depreciation question adds another layer. Companies have spent tens of billions on Nvidia hardware under the assumption those chips would remain valuable and effective for years. If alternative chips prove superior, or if technological progress makes current chips obsolete faster than expected, those billions in capital expenditures may need to be written down sooner than planned. Balance sheets across the tech sector could take substantial hits if AI hardware depreciates faster than currently modeled. This creates a fascinating parallel to electric vehicles. When you're considering buying an EV, there's a legitimate question about whether to lease instead of purchase, because battery technology and efficiency are improving so rapidly that today's model could feel outdated in 2 years. The same calculation now applies to AI infrastructure. If you're building a data center, do you commit to current generation hardware or wait for next generation efficiency? Do you lock into one provider or maintain optionality? Mark Zuckerberg is reportedly thinking about exactly this question, whether to rent AI compute capacity rather than building owned infrastructure, specifically because the technology is evolving so fast that ownership could leave you stuck with obsolete hardware, while competitors deploy superior systems. The software layer complicates everything further. Nvidia's CUDA framework has become the de facto standard for AI development. Thousands of engineers know CUDA. Massive codebases are built around it. Even if Google's TPUs or Amazon's Trainium chips deliver better performance, switching requires rewriting software, retraining engineers, and accepting transition costs that might outweigh efficiency gains in the short term. Google is trying to address this by showing that TPUs can work with various software frameworks, not just their proprietary JAX, but other tools that reduce switching costs. The question is whether that flexibility overcomes years of CUDA entrenchment and whether engineers will invest time learning new frameworks when CUDA already works. Alibaba just announced their own vertical integration strategy, developing custom chips, training models, offering cloud services, and providing AI tools across their ecosystem. They're explicitly following Google and Amazon's playbook, betting that controlling the entire stack from silicon to software provides competitive advantage over buying components from different suppliers. This all points toward a future that looks very different from the past 2 years. Instead of Nvidia as the sole provider to an entire industry, we're moving toward an environment where major players design custom hardware optimized for their specific workloads. Smaller players choose between multiple chip providers based on their needs, and competition happens across both hardware performance and energy efficiency. That's ultimately healthier for the industry. Monopolies create backlogs, reduce innovation incentives, and extract maximum pricing. Competition drives efficiency improvements, reduces costs, and creates options. The violent price swings we're seeing represent the market adjusting from monopoly pricing to competitive market dynamics. But for Nvidia specifically, and for investors who bought at peak valuations, this adjustment is extraordinarily painful. $1 trillion in value disappeared in 3 weeks, representing reassessment of how durable Nvidia's dominance actually is and how much pricing power they can maintain if customers have viable alternatives. The AI infrastructure story is far from over. We're still in early stages of a multi-decade build-out. Nvidia will remain a major player regardless of competition. Their technology is proven, their ecosystem is deep, and their expertise is genuine. But the era of unquestioned dominance with 80% market share and pricing power that supports $3 trillion valuations might be ending. The market is learning that in technology, even the most dominant positions eventually face challenges. The question isn't whether Nvidia makes good chips. They do. The question is whether being the best is enough when customers have options that are good enough while offering other advantages like energy efficiency, vertical integration, or ecosystem flexibility. 3 weeks ago, the answer seemed to be that Nvidia's lead was insurmountable. Today, $1 trillion of market value says otherwise. The chip war is just beginning. That's it for today, folks. See you in the next video.